Here, we just have an equation, and in order to kind of recognize what type of function we have here, we're going to solve for y first. So we have 3x plus 4y equals negative 3. And we're going to start by subtracting 3x from both sides because we're trying to get this y by itself. So they cancel out over here, and we end up with 4y equals negative 3x minus 3. And then we have that 4 in front of the y, so we're going to divide both sides by 4. And so we end up with y equals negative 3/4 times x, and then minus 3/4 again. Now this looks like the equation y equals mx plus b. Okay, this is the equation of a line. So we know then that this is linear. And then we want to state whether it is discrete or continuous. We don't really have any information here. We don't have any contextual information about what this equation represents. So typically, then we can make some guesses just based on variable choices. And here we have x as a variable. And x is generally used when we have a continuous function. But really, without a context, there's no way of really knowing. But I'm going to go ahead and say continuous because just based on the equation, there's no limitations on what I plug in for x. I can plug anything I want in. I could plug in some decimal values, a whole numbers, negatives, so on. And then for part C, we want to identify the slope. The slope here is m in the y equals mx plus b. And so for us, that's this negative 3/4. So slope is negative 3/4. Or if we were listing out the sequence, that would be the common difference of the sequence. And then finally, the explicit equation. Well, we have an explicit equation. It was actually pretty much given to us, but we solved for y, and that there is our explicit equation.